Hello, beautiful people. I hope you're enjoying .NET Conf so far. In this session, we'll focus a lot on AI and how to add AI inside of your Windows applications with the Windows Copilot Runtime. Now, if you're not familiar with the Windows Copilot Runtime, it's a runtime we introduced at Build this year to help developers infuse their applications Windows with AI and take full advantage of the scale of hardware that's available out there, whether it's any of the Intel devices, AMD devices, or the latest Copilot Plus PCs with devices that have NPUs on them. It allows developers to access any point of the stack, all the way from just the experiences and just easy-to-use apps that use AI, and all the way down to the level that's closest to the silicon to access, to use the tools and the frameworks to bring their own models and to run on top of those devices. Now, I'd like to show you how to do this through demos. So I'm going to switch away from slides. And for the rest of the sessions, will mostly be in demos. And I'll start with an experience that I think is fun. I want to show you what some apps on Windows are already doing with AI, starting with Paint, the app that I think people enjoy and love. And if you're using a Copilot Plus PC like I am using right now, you'll notice there's new features that use AI to generate content as the user is using the application. In this case, Co-Creator allows me to generate images based on what I've drawn on here. And I've been feeling a bit stressed, so I'm going to draw a peaceful meadow just to kind of be more peaceful. Meadow. And I need to start drawing. So I'm going to start with just a little green area down here. So let's try that. Maybe fill it up with a little grass. Let me try that one more time. Maybe like that. There you go. Maybe do a little blue on top. And then I'll do a bit of clouds. And you'll notice that as I'm doing this, the Co-Creator is generating content on the side. There on the right. So let's go ahead and add a bit of clouds here. A cloud here. Maybe a bit of a cloud here. And then you'll notice that it's generating exactly what I wanted. And this looks kind of familiar. But what I really want to show you here is if you actually open the Task Manager, one thing you'll notice on these new devices now is that there's an additional graph to show you the NPU, the neural processing unit on these devices. And the features that are being used inside of Paint are actually fully leveraging the NPU to do the whole AI, the machine learning models on this device. So for example, if I put this on the side here, and let's say I do another generation. Let's say I want to put a little line here again. Maybe something like that. Let's see what that happens. But if we look at here, we can see a spike on the NPU right there. Right? You can see that spike right there. And what you'll notice even is that the CPU didn't do anything. Same time, the GPU didn't have a spike in there, just the NPU did. Which means that we're leveraging the NPU here to offload a lot of that heavy processing of the AI functionality and clear up the GPU and the CPU to do whatever they need to do best and to process the data the way they need to. This is a little fun example, but there's also other examples of things that you're probably using every single day. For example, Snipping Tool is a great example of a way that we've added AI to the Windows experiences in here. Let's see, I think I need to click it there. Through a feature that allows you to just do text recognition, right? So you can take a screenshot, you can copy image. And this is a really easy way that we've added AI throughout different aspects of Windows that just makes the experience, it makes it better and makes you more productive to use your application. And at the same time, we're also making these experiences available to developers to use within their own applications. There's other things that we're doing in here, such as Studio Effects, which is adding different effects on top of an app, on top of the camera to offload them off to the NPU, so that way you as developers don't have to do these type of things. And you can use this directly inside of your applications as you're building them. Now, to show you how to do this, I have an app for you. So it's an app I built to demonstrate the usage of these different APIs and how to actually add models to your applications. It's a very simple note-taking application. It's using a lot of the common patterns that I think most developers are building and using today to build their applications. And we'll see how we can actually add AI throughout this applications in a way that will definitely relate to your users and will relate to yourself when you're adding these to your applications. First things first is this application is built on top of WinUI 3. It's a WinApp SDK application. It's fully .NET. The first thing I want to add in here is the ability for users to add images and to add audio files alongside their notes. You can see here we have videos, and we've also have the ability to add images. And one of the things we can do here is I can drag an image directly to my application. And as I've added it into my app, you can see here that same OCR experience I've added to this application, where I can also select the text. I can recognize the text. It even works with handwritten text, which is incredible here. It's a great model that runs on device that ships with Windows that developers can easily use as an API. Where we're adding this is by using the new text recognition API that's it's going to be part of one of the future WinApp SDK releases. And to use it, it's very simple. First thing you do, and this is the pattern that we use for all the APIs, is you request for the API to be available. And what this does is actually request the model to be available on the device. If the model is not downloaded on the device, it will prompt Windows to download that model to make it available to the application and to all the applications on the device. And once that's done, then you can create that model, load that model into memory, and then use the API to pass in an image to get back the location of where the sentences are, where the words are, as well as the orientation. You saw in the application that this was at an angle, and I was still able to recognize it, and was still able to render all the UX I needed on top of this to be able to select the text, because I was able to get that information from the API. Additional things we can do here is beyond audio, is we can also, beyond using the APIs, we can also use models. We can use a lot of open source models out there to make our application great. And there's so many out there. One of those models is Whisper, which is a model by OpenAI. Allows you to recognize audio, transcribe audio, as well as translate audio and other things. And we use that with videos, and we use it with audio. For example, here I've attached the video recordings for my classes at school, and I was able to get the text for what the professor was saying. I can get the actual timestamps of when that was taken. And we're doing this by using the open source version of the Whisper model, and we're using it alongside a library called Onyx Runtime. Now, the model, we can actually go and navigate to where we got this model from. We got it from Hugging Face, but we used a tool called Olive, which is a tool by the Onyx Runtime team to allow developers to convert models to target a specific hardware or to optimize models for a specific need, whether they need a model to be very performant or they need a model to be very accurate, and depending on which hardware it needs to run. So we're using one of the examples from the Olive runtime here to take that Whisper model from Hugging Face. In this case, they have an example of Whisper Tiny. There's different variants of Whisper. There's different size, and they run different speeds and different accuracy. So we got this model, we downloaded this model, used Olive to convert it to Onyx, so we can actually use it alongside the Onyx runtime. So we have it inside of our application. You can see here we have a few versions of it. We have tiny and we have small. Difference here being is the tiny one is very small, but it's not that accurate, versus the small one is a bit bigger. It might run a bit slower, but it's more accurate than the tiny one. And there's obviously bigger sizes going from there, and you can use them depending how you need to use them. So the first things we do is we use the Onyx Runtime API, which is the inference session here, to pass in that model path, the Onyx file itself, to the inference session. And then when we want to actually transcribe something, we need to get the audio data and then pass it through the model. Now, one way to find out how to do this is to use an app called Neutron. So I'm going to show you how that works right now. So if I open up this model here, you can see here, they're just Onyx files. The app, I'm using the web version of the app here. I can just drag this in here. Allows you to actually inspect the model and look what's inside of it. In this case, you can see here, just like any model, it's a graph with different operations that runs on top of the weights. But we can actually inspect the different inputs that the model has. In this case, you can see here, this is where the audio data is coming through, and then the different options that you can provide to the model. And then the output here is just a string, which is the recognized text. So we're doing the exact same thing inside of our application here. We are using that inference session to run the model. Before we do that, we set up our inputs. This is where we're setting up that audio tensor, which is just a set of floats that represents our audio data. We have properties that we've set up. We're also using, we're setting the logits preprocessor, which is allowing us to get that audio timestamps that's just documented for the model. We're setting up the language. And then simply we're calling run on that inference sessions with those inputs to get that string back. And once we have that string, then we can process it and we can do whatever we need to do inside of our application tool to run it. So in this case, when I run the application, I have an application here. For example, I have an audio file that my coworker has sent me. I'm just going to copy it here from WhatsApp, paste it in the application, and then it will process for a bit. It's transcribing. And we can see here, it transcribed it immediately, add it to my application, and I'm able to both play it.
Hey, Nikola, I'm going to miss a class today.
As well as see the transcription, and it's all now part of my notes application directly built in. As part of that. So I now have my notes, I have videos, I have audio files, I have photos. What really my application misses or needs is a way for me to be able to search all of this content. And AI can absolutely help us to make this a great experience for our users by using a method called semantic search. And semantic search, if you're not familiar, is the ability to search for content not by its content itself, but by its meaning. So that way you can search for a cat by searching for a lion. Or you can search for whatever it is just by what it means, not just by what the content it represents. So in this case, I can search for, let's say, number of parameters in a function. I know that's what the professor was talking about this. And I can see that it took me to the lecture 2, where my professor was talking about functions taking as input 0 or more inputs, which is the exact same thing I'm searching for, but in a completely different way and rephrased in a different way. But the meaning is the same thing. I can click there and it takes me directly to where that thing is. We're doing this, again, with an open source model that allows us to get a vector representation of content. And what that means is that I can take a piece of string and I can convert that to a multidimensional space by its meaning. So that way I can map multiple pieces of content and I can get the distance between those pieces based on what they mean. So all the animals like cats, dogs, etc., will live maybe in one piece of the space where, let's say, different, like my computers and different types of technology might live in a different area in that space. So that way when I'm trying to find something, I can get this vector representation and find where that's located in that space and what's closest to it. The way we're doing this is by using the model called All-Mini LM-L6v2. It's a great name, I'll give you that. But this is a model that's already readily available on Hugging Face. It's an Onyx model already in the Onyx format. You can simply just download this from the Hugging Face website and then use the Onyx runtime again inside of your application to run the model. The way we're running the models is exactly the same as in Whisper. So I'm not going to show you exactly that code, but what I want to show you is how we're actually doing the search, how are we doing the comparison. So here's that search function that we're running. I'm going to put a little quick breakpoint right there. I'm going to run that search one more time. Let's go ahead and walk over that search. So let's try that one more time. Let's run that search. We just hit our breakpoint. There it is. So the first thing we do is all the content that we have in our application, the notes, the videos, the audio, the pictures, we've already ran them through the model and we've stored them inside of a database based on their vector representation. And that's where these stored vectors are. You can see here we have about 490 of those vectors. And if I open one of them, you can see its vector representation. Here it is. Essentially a big list of numbers, about 384 numbers to be precise. So it's 384 dimensions in that vector space. Now that we have those 490 vectors based on our application, we can get the vector for our search term being number of parameters in a function, which is just another float of 384 numbers in here, same thing. And then to get the distance, we can actually use this function here called cosine similarity that comes as part of dotnet inside of the tensor package that allows you to get the distance between two vectors inside of a multidimensional space. And we calculate the distance between our search term and all of the vectors on our space. Now, there's many ways to do this. There's databases out there that handle all this stuff for you. We're doing this in a very simple way here to kind of illustrate how this works. But once we have the distance between our search vector and all of the different vectors that we already stored in our database, we can get the closest matches, which in this case was that the lecture 2 with that specific point in time, and we're able to point the user directly to where they need to go. So we can continue here, and it takes us directly to that same experience again, which is really great. Now, one way to actually make this experience even better is to use language models. And language models, I'm sure everybody's already familiar with language models like ChatGPT and GPT models or any of the other models that are very popular today. But what I want to show you is how you can actually run those language models locally on your device, so that way they run completely offline. In fact, I'm on Wi-Fi right now. I'm going to go on airplane mode. Everything I've shown you so far has been offline. But I want to illustrate a point that all of this stuff actually does continue working offline in here as well, which also turned off my mouse. Of course, I'm going to turn my Bluetooth back on so I can use my mouse. There it is. So one of the ways we're using a language model sounded application is, for example, for summarization. So for example, I can select all this text. I can say summarize, which we're going to send this down to a model, to a language model locally on the device to actually go ahead and summarize for us as part of that. So you can see here, the model picked up the task and is summarizing our notes to make it easier for us. So and this is, again, running completely offline. We even have a little disclaimer here that says everything is running offline on top of your application. We're also doing things like autocomplete inside of our app. So for example, let's say functions take, and let's see what this is going to go to autocomplete with. Inputs, process them, and process outputs, right? It actually did the autocomplete as part using that language model. But we're also doing things that are beyond just showing text and generating text. We're also using them to help us with reasoning on top of text and help us understand what the text means. So in this case, we have a feature to help the user quickly see what their to-dos are for their application. And we're rendering them in a more familiar UX rather than just a chat window. And we can use the language model to take what this content is, reason over that content, and then give it to us in a way that's more structured, so that way we can use it to either act on it or represent it in a more visual way to the user. The way we're doing this is we're using a library called Onyx Runtime Gen AI, which is yet another level above the Onyx Runtime for running language models. And in this case, we're using Phi 3, which is a small language model by Microsoft, but you're able to use many other models with this library. You can use Llama 3, you can use Mistral, Gemma, whatever model out there that's kind of small, that kind of works, you can kind of use this with this library. I can show you here the dependency that we have on this library. It's called Microsoft ML Onyx Runtime Gen AI, and that's the specific library that we're using to run this. And then the model we're using for here is a model that we downloaded from Hugging Face directly. Let me just go back online so I can show you the web page for that. I can actually just search for that here. Phi 3. There it is. Hugging Face, and this is already Hugging Face as well. And there's many different variants of this model. There is a variant that runs on the CPU and can run across devices. There's a variant that runs on CUDA and NVIDIA GPUs, and there's a version that runs on DirectML. Now, if you're not familiar with DirectML, DirectML is an abstraction API that allows you to run models or run machine learning tasks and abstract away the hardware, the GPUs below it, so that way you can run them across the wide variety of GPUs that run on Windows, whether that's AMD, there's Intel, or NVIDIA as well. So we've downloaded one of these models to our application here, and we've put it inside of our folder. There it is. That's the Phi 3 files that we got from Hugging Face. We've passed them on to our Gen AI API, and then we're simply using their simple API to just generate generate tokens based on what the user, whatever the prompt is. So whenever we want to send something to the model, we use this prompt that's specific to Phi. Every single model has a different prompt way that they expect the data to be sent. So in this case, Phi expects that in this specific format where it wraps the system prompt into those tokens right there. And then when we want to get things like summarization, we simply just ask the model to say, hey, summarize this text in 3 to 5 bullet points. Or we also have a function to fix spelling, where we say, hey, fix up the spelling in this content. Or in this case here, we also have one to autocomplete, where we say, hey, you're an assistant that helps user autocomplete. Please complete this beginning of the sentence for the user. You can be more specific as you need to. And then for the to-dos specifically, we're actually being a bit more specific, where we're saying you need to summarize into to-do items, but please use a JSON array format to respond to me, so that way I can take that output as JSON, but either convert it or use regular expression to get the actual information from there and then act on top of it for my experience. Now, the cool things here is that I can actually combine multiple of these models into functions that can actually do much more than that. So for example, you saw me do semantic search, but I can also use semantic search alongside a model to ground the model to the information that's within my application and allow the user to ask the model, to ask Phi about anything that's inside of my application, and then Phi can respond to it. So instead of the user just searching and looking for the information themselves, Phi can actually summarize what the user has found through a pattern called RAG, or Retrieval Augmented Generation. So to do this in action, to see this in action, I can show you here real quick. Is we have a little button. I can ask the model, let's say, when are office hours for CS10? Now, there's no reason why the model should know anything about CS10. This is my class. It's not something that's maybe might be public. It's maybe something in my notes or whatever it is, but it's still able to answer that question and even provide me the source where it actually got that information. And the way we're doing this is whenever the user asks a question, we first run a semantic search on top of that question to get the information about what the user is looking for. And then we feed this question to the model and say, hey, can you answer this question that the user has asked? Here's the contents of where you can find that answer, and go ahead and summarize that answer for the user. So that's exactly what we're doing right here. Instead of instead of ask for content async, where we're running that search first, where we provided to us as content, we're being provided the question, and we're asking the model to answer that question. So we're saying, hey, you're a helpful assistant answering questions about this content. Your system message, that's your system message. Here's the content, which I'll show you what that looks like in a second. And then here's the question the user passed in. So let's go ahead and ask the same question one more time. Let's see, when are office hours for CS10? You can see here we hit a breakpoint inside of our semantic search function to find the content. And then now we have the content within here, which is essentially just a big piece of text of that content that we found. And in here somewhere it says, hey, okay, yes, Tuesday, tomorrow, 10 to 11 is office hours that are within that video. So we're asking the model with that content to answer the question, and given that context, it's able to do that and provide that answer for the user. All right, there. There it is. And then go back, and we can go back directly to that point inside of the video. Okay, so now we saw how we can leverage both the APIs that are available to us through the Windows Copilot Runtime, such as OCR, and we also saw how we can bring models, open source models, and use them alongside the frameworks and tools that are available through the Windows Copilot Runtime, such as the Onyx Runtime, such as DirectML, Olive, and other tools in there as well. One of the best ways to actually learn about this, and the project that I showed you here is all open source. If you go to learn.microsoft.com/windows/AI, you'll be able to learn all about the Windows Copilot Runtime. In fact, all of the samples are directly there. So you'll be able to find this sample alongside other samples that allow you to show you how to use the Windows Copilot Runtime. Now, just to recap, There's already a ton of experiences built with the Windows Copilot Runtime, both inside of Windows 11 and part of the applications that come as Windows 11, but at the same time through applications that you might be already using that are already out there. They're using open source models and APIs. And one way to learn how to do that is just by using those applications and learning how they actually accomplish what they are doing. In terms of the APIs are available through a library called the Windows Copilot Library. Now, this is a library that exposes a set of on-device models that ship as part of Windows that will allow you to leverage those models inside of your applications directly through a very simple API, just like I showed you with OCR. Two of those APIs are going to be available in the upcoming experimental releases for the WinApp SDK. One of them is Phi Silica, which is a language model that's specifically optimized for the NPU, allowing you to leverage that without you having to pull in any kind of model within your application and leverage the model that's already on the device or downloaded through the API. And the API is very simple to use. As you can see here on the screen is you can make them all available and ask Windows to download that model for you to make that available on the device. If a different experience has already done this, the model will probably already be on the device for you to use. And then you can simply load the model in memory with create a sync, and then send a prompt to get a response back within your application. And then you can do similar experiences like I showed you in the Notes application with this model that's already built into the platform. And then following the release of these two models, we'll also have additional APIs available, things such as vector embeddings to allow you to do things like semantic search like I showed you, and RAG, text summarization, and many more APIs that we're working on to make available as part of the API and easy to use library. Beyond the library, when we get to the bottom layer of bring your own models, that's when we get to the actual APIs and frameworks. And DirectML is a single hardware abstraction API that allows you to optimize and deploy models across the whole scale of Windows devices, over the 1 billion Windows devices, whether they're running an AMD, an Intel, or an NVIDIA GPU. And we're also working to include NPUs under that umbrella as well, so that way you will be able to also target NPUs, as all the NPUs across the different silicons through DirectML. DirectML also supports 4-bit quantization, so that way you can make your models as small as possible while still maintaining accuracy, and be able to run them across multiple devices. And then you can use it today. It's been available for many years now, and it fully supports the GPUs, and you can download it as a NuGet package inside of your applications. The Onyx runtime and Onyx and all its suite of tools allow you to use models cross-platform. Now, Onyx is a cross-platform and open source model format to represent model graphs, and the Onyx runtime runs across all the different platforms, allows you to run those models on top of any execution provider, such as DirectML. The Generate API I showed you is specifically for language models and generative AI. And it's available for you to use today with many of the different models, and it also supports different languages as well. And then Olive is the tool that I showed you for optimizing and making models optimized for the different hardware, or helping quantize them, or even fine-tuning models for whatever you need them to do. And then finally, one of the tools that you should probably take a look at is the AI Toolkit for Visual Studio Code. It's a great way for you to get started with language models and to experiment with language models. It allows you to download them and to try them out directly within Visual Studio Code. It allows you to also fine-tune and optimize those models using Olive. It wraps Olive into a really nice user experience where you can provide your own data and then fine-tune them for whatever you need. And then you can deploy this application either on the cloud or on your device. So hopefully this session was educational. There's plenty of more for you to learn and to try out. So I really encourage you to go check out aak.ms/WCR to learn more about the Windows Copilot Runtime and to kind of stay tuned for everything else that we have coming up in the upcoming months. So thank you, and I hope you have a great rest of your day.